In this session of video, I'm going to explain class templates, and variable template, and alias template, and type function. In our previous video, video 3 is our previous video. This is our current video. We implemented GCD, greatest common divisor algorithm, using Euclidean algorithm, and we expanded to get arbitrary number of arguments like this using periodic template functions. And in case of template function, we can overload. The function names are the same. We use overload, but in case of a class templates, we are not overloading we cannot overload the class templates. Instead, we use specialization. So, in this session of video, we will ensure that T1, T2, and all types are of the same type. T1, T2, and all other argument types should be the same to evaluate GCD. So in this session of video, I will implement how to make sure T1, T2, and types are of same type using class template, variable template, and alias template, and type functions. For class template, we define class template like this. Template, type name, we introduce type name, parameter, for example, T, then class or struct, class name, for example, ST or same type. For example, if we define class name like this, we will introduce one more parameter. Two template parameter T1, T2 is introduced. Then we define class template like this. We can, instead of using class, we can simply use a struct like this. Then this is primary template. We can specialize it like this. For example, template, type name, T, struct, ST, of same type. See, the class name is the same, template type name is type parameter can be different, but should be of same. We need T. Say template argument. This is the template argument T. Template parameter list. It has two parameters, so it should have two parameters. Then we can define like this: static data member, static constant bool value like true. We can define like this. So this is primary template. This is primary template class, primary class template, and this is specialization. This is primary, this is specialization. This is partial specialization. Partial specialization means template type is still used. There is another specialization, but this is partial specialization. There is another specialization called explicit specialization. For example, if we create another template specialization, template, here we can have empty list, then struct, the same name, st, of, same. Then we need to provide two parameters, two arguments here, int, for example. Then if we define, this should be the same type, so we can say static, constant, bool, value, true. If we define this, this is specialization, this is specialization, this is primary template. We always have to declare or define primary template first. Then we can use, this is partial specialization. In case of we are using partial specialization, we are using template parameter like this. In case of this, it is called explicit specialization. It is called explicit specialization. Then we provide a template argument, type argument like this. So this is the concept of class template, primary class template, partial specialization. This is explicit specialization. We will use this concept to implement, to make sure type 1, type 2 are of same type. Then we will introduce variable template. To introduce variable template, we will use, I will show you in the code. Then we will use alias template. Then we will create type functions. Such mechanism is actually called type mechanism. I will move to my computer and I will implement the code. We select collapse all, then unselect anything, then create a folder O4 type function 1. This is type function 1 folder. Then we create a file is same cpp. Okay, we include IO stream, then include utility, then here we are going to create template function first. Template class, type name T1, type name T2. Then struct, we name st is same. We are creating a primary. This is primary class template. We can declare it as class, but it's eventually the same, so we will use a struct. I will make it shorter like this. Now we will specialize. This is primary class template. We will specialize template, type name T, struct st is same. Then we need to provide two type argument. This is partial specialization. Partial specialization of st is same. Please note that T, the parameter, the template parameter list is replaced, substituted with two template argument t and t. Because it takes two argument, it takes two template argument. Primary class template takes two template argument parameter. It has two template parameter. We have to provide two template parameter argument like this. Here, static constant bool value will say true because true, because two type tt is the same, but t1 t2 can be different, so we will define like this. Or we can say here static constant bool value false. We assume t1 and t2 are all different, are of different types. Okay, so we define we will use these two functions, these two class, template class, primary class, and partial specialization. Then we define template type name t1, type name t2. We are using constant expr, bool is same. This is, please note that we introduced constant expr. We introduced constant expr, bool, and is same. We will use st, is same, t1, t2. T1, T2 has class T1, T2 has member value, so we can set like this. Here, constant expr is different from constant. I will explain it. Constant expr means compile time expression. Constant expr means compile time expression. It does not mean constant. Whereas constant means the value. Constant means value cannot change either during compile time or learn time. So this is so-called variable template of type bool. Now we will use it int main. Okay, we will use it int a, for example, signed short, b, I would say s, integer I. Okay, we will use it if is same. We are using this this construct variable template I. No, we have to provide int short. We have to provide a type here. Then say std cout of same type, else std cout of different type. Okay, Now we will run it because int and short is actually replaced t1, t2. Then this class is evaluated because t1, t2 int and short are of different type. This false will be displayed. Okay, then it will be of different type will be printed out. I saved and I will build it. This is rational number cd o4 type function 1. So G++ is same C50. I would say IEXE. Okay, of different type. So it gives different type. For example, if we try int, they are of same type. So this kind of class templates are called type function. It's actually not type yet, but we will make it into type function. Before introduce type function, I want to get the type of variable a. Instead of this, we can change like a DECL type of AI. DECL type gives us type of variable I. Then DECL type S gives type of variable S. So we can try it. So of different type, it means I and S are of different type. If we put it int of same type, then if we try it again, of same type. So DECL type, expression is type of the expression. Type of expression. Okay, please remember the DECL type. This is C++ keyword. Now we will implement another class. We will generate it. We will make it arbitrary. These are currently supposed to template argument. We will make it arbitrary number of template argument. Type name T1, type name T2, then type name types struct st is same. Okay, here we are doing static constant bool value. Please note it carefully. st is same. We are using this function. We are using this class. Then T1, T2 value. We are using this class, partial specialization, and st is same T2 types. We are calling this again. In this case it calls it back because it becomes now primary primary class template with 2 or more template parameters. It now becomes partial specialization. Partial specialization. Here, to make it partial specialization, we have to turn like this. Partial specialization with 2 template parameters. Please don't forget this. So this has all three class. ST is the same. ST is the same. ST is the same. Is implemented 3 times. All 3 times. This is the primary class template. Should always proceed first. Then we are specializing with the 2 parameters. In this case, these 2 parameters are compulsory, and the types, the trailing periodic template part is optional. So types means 0 or more. So these are specialization. These 2 are specialization. In this case, we are using this part belongs to these 2 cases. These 2 cases. Here, I will explain it. Use code at use code defined for 2 template parameter case. Okay. Two template parameter case below. Okay, so this is recursive. This part is recursive. It uses itself again. So this part is recursive. So please try to understand this mechanism. This mechanism is used quite a lot in C++ template metaprogramming. So now we defined, we can try like this. int double d 5.6, for example. We can now try the ECL type D. Okay. Now we build and compile. There is some error. I made a mistake. We also have to fix this. Type name, types, then here types, like this. Saved it and build again. Okay, of different type. See, D is of double type, so different. So we change it back int. Now try it. Okay, of same type. This way we define this way we implement it for arbitrary number 2 or more types. We can check if if the types are of same type. For example, we can test. Okay, I will move on next. Then we will implement another kind of type function here. In this case, I will name of same type. Now we are creating type function, template, type name, T1, type name, T2, st, struct, st is same type. I will define like this. This is primary template. Primary template. Please note that this type, this class is, and this class is different. This is same. This is same type. Okay. And now I make partial specialization. Specialization again. Type name T. Struct st is same type. Then we have to make, this is specialization of this class template. We have to provide two template parameter, specialization with two template parameter. Now we are defining like this using type T. This is type function. We need to know how to use them. Okay, we want to know how to use them. I will disable this part. Okay, so, and I will define another function, now this is template, this is called variable template. Now we are using alias template, type name T1, type name T2. Okay, using say is same type. We are defining functions like that. Is st is same type T1, T2 type. Okay, then we have to put type name keyword here, type name, because this type is defined in this class. We are not sure if it is type or not. We have to provide type name keyword to mean that this is type defined in this class. So we are using like this. This is called alias template. We are using this class, this structure template class. This is specialization, more specifically partial specialization. Now we are going to use is same type. Okay, we can say is no, I will say same type. I will name like this. Then we say same type int. It gives the same type C. For example, I plus S. Okay. So we can define this returns type. This returns type. This same type returns type of two int and int. Only when t and t are the same. Okay. Returns
I would say yield. Yields type int. Type when two template arguments are of same type. I will write like this, save it, rebuild. Okay, it compiles and builds successfully. If we change it to short, it doesn't work because these are of different type. In case it is different type, this type is not defined. It's the same type when two arguments are of same type. Otherwise, no type gets yield via yielded. Okay, so I will change it back to int. So instead of int, we can test two type I and s like this. DECL type, DECL type I's type, DECL type S's type. Then we can define like this. Okay, now try it. Okay, it works. It works successfully. I hope you understand what type function means. It returns type. Type function means this is called type function. Or this is called a type function. Okay, so this way we can call type function. Now we will generalize it. We will generalize type function. Now how we do that? Now we try like this. Template, type name T1, type name T2, type name types struct st is same type. Okay, now here, now we can inherit like this. Public st is same type T1. Okay, T1 st is same type T2 types. Okay, but here this is type 1. This is the same type, requires 2 and more. So we provided one type here, and we want to provide one more type. This is one more type. Then we have to do this. Type name type. Okay, then we are providing two types. This forms two types. Like this. Okay, then we implement this. This is recursive. Same type is defined here, and same type requires 2 or more type. Then I use another same type here. So to make it work, always work, I would make it another class, struct non-type. I make a class non-type. here at this time. Now this becomes partial, specialization of st is same type. So we have to make changes here, t1, t2, like this, of two type. We have to fix like this. And here, using type, non-type. We define the non-type here, non-type. Then we can define like this. So if these two types are of same type, it will be defined as t of same type. If they are of different type, we assume t1 and t2 are of different type. Okay, so non-type, or we can change it to void type if we don't like this type. Okay, so save them, control save them. Now we will test these for arbitrary number of type of same type. You can test like this. And here we also have to update it, type name, types, then here types. So now we can say DECL type here D, like this. So let's compile, build and compile. See, wrong, because this is of not type, this is non-type. So if we change it, something wrong. Parameter perfect. Oh, sorry, we made a mistake here. We have to expand it. Okay, it works. Okay, because it all works because this is of same type. If we change it to different type, for example short, it won't compile. It won't compile here. It won't compile because it gives us error message here. Now we understand what it means, all this stuff. We understand all these things. So up to here, this is called alias template. We learned alias template. So this is class template, and this is variable template, and this is alias template. We now copy source code from our previous video here. From here to here. Sorry, I copied, then paste it here. Then we can now change it like this. Instead of this, same type, T1, T2. Also we can change it here. Same type, T1, T2, then types. Now we call it, I disable it. std cout gcd isd I S D GCD I S D, and we will make one more changes here. We can do this same type T1 T2 like this. Now save it, Ctrl S, G++ is same CPP SEXE IEXE, and okay, it works. Now what about if we change it to short? It may not work because of this. Okay, it doesn't work. Anyway, in this conclude, I will change it back to int. In this session, we learned how to create periodic templates and templates alias, partial specialization, things like that. In next video, we will extend type functions more, and we will learn how to get common type. Say, in this case, how to get T1, T2 common type of two types, common type of two types in next video. Thank you for watching.